Addition and subtraction of rational expressions is very similar to fractions. So basically you're going to need a common denominator to add these rational expressions. For example, if I'm to add these two fractions 2/3 and 4/3, since they have the same denominator, I keep the common denominator and I add the numerators, which is 2 plus 4. That's going to give me 6/3, and the last step really is to make sure you reduce anything that can be reduced. So my final answer is 2/1 or 2. Now if I want to add 2/3 plus 4/5, since the denominators are not the same, I'm going to need lowest common denominator. I'm going to abbreviate LCD, and between the 3 and the 5, since they have no common factors, it would have to be an LCD of 15. So I multiply the numerator and the denominator by whatever factor is missing to make it look like a 15. So this guy is missing a 5/5. This guy is missing a 3/3. That's going to give me my new fractions with common denominators, 10/15 and 12/15, which gives me 22/15, and since nothing reduces further, I'm done. So there's really two things. I can either have the same denominator and carry on with my business, or if I don't, I need to get a common denominator and then carry on with my business. So let's go ahead and first look at adding rational expressions that have the same denominator. We'll focus on something that looks mainly like part A. Okay, we're going to add or subtract accordingly. So part A, we have the same denominator, check, check. All I have to do is combine the numerators. So I'm looking at 1 plus 3, they're like terms. That's going to give me a 4, and I'm pretty much done. Part B, I have check, check. Again, same denominators, so keep the common denominator, and then I have to combine the numerators. They're not like terms, I can't combine them, so the best I can do is just leave them together as 2 plus x, or I could say x plus 2, put it in descending order, over x minus 1. They're both okay. Part C, again, check, check. They're both the same denominator, so keep the common denominator. Add the numerators, which we can't because they're not like terms, so just leave it as an x plus 1. And then notice, like this problem in part A, I can actually in my last step do some reduction, and when I do the reducing, my final answer happens to be just A1 in this case. Okay, part D, it looks like we are subtracting, and again, check, check, we have the same denominator. We just have to worry about the numerator. So I'm going to keep the common denominator of x squared plus 6. I have to be very, very careful because there's a minus in the middle, and when I have a minus in the middle, that minus actually distributes and affects both items, so that's a big caution, that come after it. So basically you really have like these invisible parentheses around the binomial that comes after the minus sign. So in doing that, I get 2x minus 1 minus 2x and then minus 1. Again, we're going to distribute the negative sign is what's happening there. Now I can combine the numerator. It looks like I have like terms that cancel out, and I have -1 and -1, which is -2, and then x squared plus 6, and I cannot do any more cancellations or reducing, remember, because there's a link of a plus between the x squared and the 6. Part D, again, there's a lot going on, but check, check is all I'm worried about because they have the same denominator. So in my first step, I'm going to make one big bar and say, let's go ahead and combine the numerators. There's no negative or anything to distribute, so I have 3t plus 2 minus 2t, and it looks like I do have like terms in the numerator. So t squared minus t minus 6, I get a t from these two guys. 3t minus 2t is 1t plus 2. So I'm almost done. I just need to see if I can factor the denominator and possibly reduce this rational expression any further. And in checking that out, we can see that we can factor with a product of -6 and a sum of -1. That would be a -3 and a +2. And since these guys are multiplied, I can actually now reduce these, and it looks like we have a 1 left in the numerator. So my final answer is 1 over t minus 3. The next case we look at is, what if we have different denominators where they don't match up and I don't have my check going? So if they're different, the very first thing to do is to find the least common multiple, which your book calls the LCM, also known as the lowest common denominator. And once you find that, you're going to adjust the denominators and make them the same and continue. So essentially, you're going to be doing this business that we did in part B. You're just going to find the lowest common denominator, or LCM, adjust the denominators, and then carry on adding the numerators. Let's practice finding the LCM first. So we're not going to add or subtract. The only thing we're going to do is just find the lowest common denominator or the least common multiple. And basically what we're going to do is we're going to pick each different factor, and then we're going to pick highest power we see. So that's basically sort of a shortcut of how you think about finding the LCM. So when I'm looking at the first one for the LCM, I definitely see an A and I definitely see a B. So my LCM will actually involve an A and a B. Now under the first denominator I see a squared for the B, so I pick that highest power. Under this denominator I see a square for A, so I pick the highest power. So my LCM is A squared times B squared. It's basically a big bag that contains my denominators as factors in it. So A squared, B squared, inside of it contains the first guy and the second guy. Let's go to part B, LCM. Well, I see this 2x minus 1 that I can't factor any further, so I keep that as a factor that I see. I see this 3 times x, so I pick the 3 as one factor and the x as another factor. And all of these factors have degree 1. Exponent 1, exponent 1, and this 2 has exponent 1. So I've picked each different factor I see, and I've picked the highest exponent. I'm basically done with finding the LCM. So basically all the factors I saw, I just picked them from the denominator. LCM for part C may require a little bit of work first because this guy is not factorable, however this guy is. Let's factor that first. X plus 2, x minus 2. I have to do that first before I find the LCM. So now I look through my denominators. I see one factor, x plus 2, I pick it. I see x plus 2 again. I don't pick it because I've already picked it. I've already accounted for it in my big bag. Then I see this different factor, x minus 2, so I pick that one because it's different than the first one. Now the highest power here is 1, the highest power here is 1, and the highest power here is 1 as well, so 1 is the highest power that I'm going to keep for each of the factors. Notice this is like a big bag that contains this guy, and it also contains this guy to the right over here. Okay, more practice of getting LCM. So LCM, again, requires me to factor first. This guy is okay. This guy I can factor as x plus 2 and x plus 2, which really ultimately under that denominator can be rewritten as x plus 2 squared. So pay attention to that squared, which means I have two of them identical under the same denominator. So the LCM is x plus 2 because I see that factor right here. Then I see that factor here again repeated, and I have to account for that repetition, which means the highest exponent I see is 2, so my LCM is x plus 2 and another x plus 2. Again, it's a big bag that contains the first x plus 2, and it also contains two identical x plus 2's to account for the second denominator. Notice in part C, I only picked x plus 2 once because it had a power of 1 under one of the denominators. The reason I picked this twice is because the power is 2 under only that one individual denominator, so I have to account for it twice. Part E, it looks like I can factor this guy. I'm going to pull out a 2, x plus 2. I can also factor this guy as an x plus 2 and x plus 3. So now my LCM definitely has to have an x plus 2, definitely has to have this different x plus 3, and also notice it has to have this 2 because a 2 is its own different factor. So these are the three factors that I need, and I only need an exponent of 1 for all of them because under each denominator it only occurs once, so I don't need to account for this twice. This big bag contains these two guys, and this big bag contains these two guys as well. That's my LCM. So now we're finally ready to add rational expressions with different denominators. So we're going to see different denominators and make them look the same. Alright, let's add or subtract the given expressions. LCM, like we talked about earlier, for this guy, I need an A, I need a B, and each one is squared individually, so I need them to be squared. Now, these denominators, I need to make them look the same, so I multiply the first one by A squared over A squared, and I multiply the second one by B squared over B squared, and essentially what I get is same denominators. So after adjusting the denominators, I get my check, they're both the same. Keep the common denominator, combine the numerators, that's a squared minus b squared since they're not like terms. And in the process, I'm going to go ahead and factor the top, a plus b, a minus b, because there are differences squares. But notice nothing really cancels out or divides out because these are both linked with the plus and minus. So this is okay, an acceptable answer. And so would this, since nothing really reduces in the last step. Part B, the LCM requires both denominators, so x plus 2, x minus 1, which means the first one is missing an x minus 1. I'm going to put one on top, one in the bottom. And the second one's missing an x plus 2, put one on top, one in the bottom. And by doing that, I've made the denominators look the same. So now I have first denominator that contains what I need, check. Second denominator that contains both things I need, check. And I can write them all over that same denominator. They both contain the same items. Now in the numerator, I'm supposed to add these, but order of operations says multiply first, then add. So I have to distribute in the numerator and then see what addition comes about. 4x minus 4 plus, there's no negative to distribute so I'm safe, x squared plus 2x. Now I can add these guys because I've done my order of operations correctly. That's going to be in descending order, x squared plus 6x minus 4 all over x plus 2, x minus 1. And then if I try to factor, we can't factor the numerator. It's not factorable, so I just leave my answer as is. Okay, let's subtract these two. I'm going to need to factor the denominators in order to get the LCM, and it looks like the LCM requires both factors. And since the exponents are 1, I don't need to get them squared, I just need one of each. This one is okay, it looks like the LCM. This one is missing the n plus 3 from top and bottom. And once I do that, I can have my check, and the same denominator. And in combining the numerator, I have to be careful because I'm actually distributing a negative 8, not a positive 8. So 4n minus 8n minus 24 is what I get in the numerator. I combine like terms, that's negative 4n minus 24, and then I'm going to try to factor the numerator. Looks like we can't reduce any further, so this is okay or this is okay. Both are